Alright folks, we're back at it again. This is section 3.2, part 2. We're starting right at the top of page 5 of your chapter 3 notes. And we're starting here with theorem 3.7, the converse of the alternate exterior angles theorem. That theorem tells you if two lines form alternate exterior angles that are congruent, then the two lines must be parallel. This works very similarly to the corresponding angles postulate, or the alternate interior angles, the converse of the alternate interior angles theorem. So this diagram is going to be used for both of these. And if we're talking about alternate exterior angles, you look at 1, 2, and 3. 1 and 2 are the alternate exterior angles. So we're saying if you know that angle 1 is congruent to angle 2, then you're allowed to conclude that A is parallel to B. Line A is parallel to line B. Now the next one is the converse of the same side exterior angles theorem. Remember, the same side exterior angles, that's one of those pairs that are going to be supplementary, not congruent. So this theorem says if two lines in transversal form same side exterior angles that are supplementary, then the two lines are parallel. And when you're looking at our diagram, 1 and 3 are same side exterior angles. They're exterior because they are outside lines A and B, and they are same side because they are on the same side of the transversal. So we can say that if the measure of angle 1 plus the measure of angle 3 equals 180, then A has to be parallel to B. Right now, example 3 wants us to prove the converse of the alternate exterior angles theorem. Alright, so we need to fill in the given and the prove. For the given, we can look at these symbols over here. We see that 1 is congruent to 2, so we'll have angle 1 is congruent to angle 2. And that also could be pulled from the hypothesis up here. It says if you have congruent alternate exterior angles. So that's where that comes from. The proof always comes from the directions, and if it's in the form of if-then, the proof has to come from the conclusion. So it says the lines are parallel, so we're going to try to prove that A is parallel to B. We'll start off our proof here as usual with the given. So we can say that 1 is congruent to angle 2, and our reason is given to get us started there. You look over the diagram here, you also have angle 4, so we know that's going to come into play here. If you look at how 1 relates to 4, those are a pair of vertical angles. So we know for sure that they're going to be equal. So angle 1 is congruent to angle 4. And now we need the reason for that. Well, because they're vertical angles, and the vertical angles theorem tells us that. So we put vertical angles theorem. And we don't want to just put vertical or vertical angles there because that's kind of lazy and incomplete. And we don't want to be that way. Alright, so we're building here and we're working, and eventually we're going to say that A is parallel to B. We have to build off some of the previous information because we've used all the symbols over here. So you see that 1's equal to 2 and 1's equal to 4. Well, if both of these angles are congruent to angle 1, they have to be congruent to each other. So angle 2 is congruent to angle 4, very similar to what we've done in some of the other proofs. And now we need a reason, and this is the one where you have the options. You get to call it the substitution property because you're getting rid of angle 1 and replacing it with something you know is equal to angle 1, putting 4 right in its spot when you say 2 is equal to 4. Or you could just as easily say the transitive property. So whatever property makes more sense to you in that situation, you should probably use that more often because it's more likely to pop into your head when you're trying to come up with these things. Alright, we're trying to show lines that are parallel, and we have different pairs of angles here. The last thing we just showed was 2 is equal to 4. You go back over to the diagram, 2 and 4 are a pair of corresponding angles. And the converse of the corresponding angles postulate says that if you know corresponding angles are equal, and we just showed that, that means the lines have to be parallel. So we can now make the conclusion that A has to be parallel to B. And our reason there is just what I quoted a second ago, the converse of the corresponding angles postulate. Converse of the corresponding angles postulate. And just like the we did in part 1 of this section, you can't say corresponding angles postulate, you have to say converse of, because we're making the conclusion that lines are parallel, and the converse is the one that has the conclusion that lines are parallel. And you could have done this multiple ways. You could have used different pairs of angles, you have maybe different numbers sitting in different spots, and used the converse of the alternate interior angles theorem or something like that. This one happens to be building off of the converse of the corresponding angles postulate. Right, so we start off by knowing that exterior angles are equal, and we concluded that lines A and B must be parallel. And the fact that we use no measurements and no degrees whatsoever means it's not going to work. Not only is it going to work for this particular instance, it's going to work for all situations. As long as you know alternate exterior angles are equal, the lines must be parallel. Now we're going to use a couple of these ideas, get away from proofs and go back and do a little bit of algebra. Example 4 wants you to figure out the value of x. They're going to make lines n and m parallel to each other. So you look over here at our diagram. You have two lines. It looks like they're parallel, but we can't assume that unless we know it. This is 39 degrees. That's described as 3x plus 6, and you have your transversal here. So you ask yourself, what kinds of angles did they give us information about? Well, this angle here and that angle there are a pair of corresponding angles. And if these two lines are going to be parallel, corresponding angles must be congruent. So we're going to set the one equal to the other. And now we can solve for x, just like an algebra problem. We're going to subtract 6 from each side, and then divide by 3, and x is 11. So it says find the value of x. We did that exactly. So whenever x happens to be 11, it's going to make this angle just the right size to match this angle. And as soon as they match, guaranteed n has to be parallel to m. Because if these two degrees are different in any way, it's going to make those angles a little bit slanted, and they're now no longer going to be, those lines are no longer going to be parallel to each other. Alright, so let's turn the page. We have a practice problem set up for you. The practice wants to know the value of y that's going to make A parallel to B, those two lines. So you're going to look at, see what information they gave you. Ask yourself, what kind of angles are they? And then the very next thing you should ask yourself is, are they a kind of angle that should be equal to each other? Or are they a pair of angles that should be supplementary? If they're equal to each other, you're going to set them equal. If they're supplementary, you're going to set them up so they add up to 180. So pause the video. Take a few minutes to figure that out, and then start the video again, and we'll show you the answer. Alright, you have 4y plus 20, and you have 6y down here. Those are a pair of same-side exterior angles. They're exterior because they're outside of lines A and B, and they're same-side because they are on the same side of the transversal. Same-side exterior angles are one of the pairs of angles that are supplementary. And even if you didn't happen to remember which pairs are which, you take a look at this angle here. This is clearly obtuse, and this angle here is clearly acute. So there's no way those guys are going to be equal. So this is not a situation where we want to set those two things equal to each other. So let's set them up. If they're going to be supplementary, they have to add to 180. So you have the 6y, which is the one angle, and we're going to add it to the other angle, which is 4y plus 20. And together they have to add up to 180. And so there's our little algebra equation. We need to solve it for y. So the first thing you want to do, most people would combine like terms. So you get to 10y plus 20 is equal to 180. Now from there out, it's just a two-step algebra equation. You're going to get rid of the 20 first, and since that's addition, you want to subtract 20 from each side. and then divide by 10 to get rid of that multiplication. So y is 16. So whenever y happens to be 16, it's going to make this angle just the right size and that angle just the right size to make them supplementary. And as soon as they're supplementary, line A has to be parallel to line B. That wraps up section 3.2. And we will see you later when we talk about parallel and perpendicular lines.